Let's write a context-free grammar for the language composed of the strings that are not in the form a to the n, b to the n. So this is the complement of the language a to the n, b to the n. The alphabet here is a and b. So we will accept all the strings other than a to the n, b to the n. For example, we will accept strings with only a's or strings with only b's, or if there's a sequence of a's followed by a sequence of b's, then the number is not the same. So we have more a's than b's or more b's than a's, or else we will accept b's followed by a's. Also, we will accept any mix of a and b. The only type of string that will not be accepted here is when we have a sequence of A's followed by a sequence of B's, and the two letters have the same number of occurrences. Also, according to the definition, epsilon will not be accepted. So we need to write the rules that accept any string in the form of the blue strings, but that cannot accept these two types of strings. Let's say, for example, we have a variable t that will yield to ATB, so that here we can say that there is a recursion on a in the beginning, b at the end, so it's in the form a to the n, b to the n, but the last t here, when we will end this recursion, the last t will be either ra or br, with r another variable that accepts any sequence of a's and b's. This sequence may be epsilon, it may be a's, 1a, double a, 3a. It may also be any sequence of b's, b, double b, triple b, and so on. It may also be any mix of a's and b's. Let's take, for example, this string double a, triple b. We will choose the rule t substituted by ATB. Then the t in the middle here will be substituted to ATB also. Then the t in the middle will be BR. Since we have finished the double A here and we have just one B in the middle here, so we will choose BR, and then the last R will yield to epsilon, so that we will accept double A, triple B. Here we have another derivation. It consists of the derivation for the string a double b, a b. So again, we will choose the rule ATB. So we have this a and this b have appeared. Then for this t, we will choose br, since we have a b here in the second position. So this t will be br. Then we have a variable r here. According to this b, we will choose b yields to br, since we have possibility to choose this rule. Then for this r, we will choose ar, since we are reading a in the input, so we will choose r yields to ar. Again, we have a variable r here, and it will be substituted by AR, since we have in the input another A here. And now all the symbols of the input have appeared, so the last R will yield to epsilon, and we will obtain the desired string. Now let's take an example of a string in the form a to the n, b to the n, and show that it cannot be generated by this grammar. Take, for example, double A, double B. So we'll start with the variable t, and we will choose the rule ATB. Then for this t in the middle, we will choose again t yields to ATB, and we will have double A, a variable t, and double B. All the symbols of the input have appeared, but we have another variable here that has to be substituted. However, we can't substitute it by anything that leads to epsilon, since double A, double B have appeared. Uh, Always we need here another A at the end of this string, or a B at the beginning of this string in the middle. So we cannot generate double A, double B. And same for all the strings in the form A to the N, B to the N. So this is a grammar that can generate all the strings that are not in the form A to the N, B to the N.